Junction diode has the unidirectional property, that is, it conducts only when it is forward bias, and in reverse bias condition it do not conduct. Therefore, this property is used to rectify the alternating voltage, and circuit is called the rectifier circuit. So we can say that rectifier circuit is the circuit which convert AC into DC. There are the two types of the rectifiers. One is half wave rectifier and second is full wave rectifier. If we draw the circuit of the half wave rectifier, the input voltage Vs, this is the source voltage, is applied at the primary coil of a transformer. It is a step down transformer which reduces the voltage, and across the secondary coil of the transformer a diode is connected, and then a load resistor is conducted across which we take the output voltage. This is the circuit of the half wave rectifier. So if we draw the waveform at the terminal A and B across the secondary, the voltage has the reduced value, that is, its magnitude is less than the source voltage, but frequency will be same. So voltage across point A with respect to time will be similar to the source voltage, and suppose it is a sinusoidal voltage. So for half cycle voltage is positive, for next half cycle of the voltage is negative, and then alternatively they are positive and negative. Correspondingly, if we draw the output voltage VO, when the point A is at higher voltage than B, that will be in forward bias condition. So this will say forward bias state. And when the A is at a lower voltage than the B, then the diode will be in reverse bias. In forward bias, diode conduct and the voltage appears across the load resistor. So we can say that for positive half cycle at A, the diode conduct and we have the same voltage at the load resistor as a output. And for next half cycle, it remains in reverse bias state, so do not conduct and voltage does not appear at the load resistor. Again, for next half, we have the output voltage and then 0. So this is the waveform of the output voltage. From the diagram, we can say that frequency of the input voltage and the output voltage will be same. If the frequency of the input voltage is suppose 25 Hz, then frequency of the output voltage will also be 25 Hz. The input voltage has the time period T, then the output voltage will also have the time period T. The equation of the output voltage is Vm, this is the maximum voltage or peak voltage, into sine omega t. Therefore, average voltage or the DC output voltage will be equal to 1 by time period integral 0 to t by 2. The waveform is sinusoidal and its value is Vm sine omega t dt, plus then t by 2 to t and value is 0 dt. This integral will be 0, therefore we have 1 by t into Vm integral 0 to t by 2 sine omega t dt, and it will be equal to Vm by t. Integral of sine omega t is minus cos omega t by omega, and limits are 0 to t by 2. It will be equal to minus Vm by omega t, and then we put first upper limit, it is cos omega into t by 2 minus then lower limit cos 0. Cos 0 is 1. Omega t by 2, it is 2 pi by capital T into t by 2. T and T get cancelled, 2 and 2 get cancelled, and it simply remains pi. And cos pi is minus 1. Therefore, we will have minus Vm by omega t into minus 1 and minus 1. It will be equal to, this is minus 2 and minus minus plus. Therefore, we will have Vm by omega t into 2 equal to, further we can write it is Vm by omega can be written as 2 pi by capital T into t into 2. 2 and 2 and 2 get cancelled, T and T get cancelled. So simply we remain with Vm by pi. Hence, VDC, DC voltage or average voltage for the half wave rectifier will be Vm by pi. Next, we will find the root mean square value or the RMS value of the output voltage. And this will be root mean square value of the output voltage equal to, first we will take the square, then mean, and after that root. So it is the root of 1 by t, it is the time period to take the mean. Then integral 0 to t by 2, for which the output voltage is Vm sine omega t, and we take the square of it, dt. Then for t by 2 to t, value of the output voltage is 0, so 0 square into dt. This will be equal to a square root of 1 by t integral 0 to t by 2 Vm square sine square omega t, and this term is 0, so remaining is dt. This will be equal to square root of 1 by t. Vm square is constant, so it is taken out, and remaining is 0 to t by 2 sine square omega t dt. It can be written as integral Vm square by t into integral 0 to t by 2, and sine square omega t can be written as 1 minus cos 2 omega t by 2 dt. Therefore, it is equal to square root of Vm square by t, and this t2 is also constant, it is taken out, so it is 2t, and remaining is integral 0 to t by 2 1 minus cos 2 omega t dt. Now integrating, we will have square root of Vm square by 2t integral, taking the integral of 1, it is t, minus an integral of cos 2 omega t will be sine 2 omega t by 2 omega, and limits are 0 to t by 2. Substituting the limits, we will have Vm square by 2t integral, this value have first upper limit, it is t by 2 minus sine 2 omega into t by 2 by 2 omega, then lower limit minus 0 plus again it is sine 0 is 0. Therefore, it is equal to this sine 2 omega into t by 2. It will be equal to sine, this 2 and 2 get cancelled, so it is remaining omega t, and sine omega t is equal to 2 pi, and it is equal to 0. So this term is also 0. Therefore, we will have square root of Vm square by 2t into t by 2, and t get cancelled. So we will have square root of Vm square by 4, or we can simply write it is Vm by 2. Hence we can say that DC or the average voltage at the output will be Vm by pi, and RMS value of the output voltage will be Vm by 2. Using these values of the DC voltage and the RMS voltage, we can calculate the efficiency of half wave rectifier, which is given by eta equal to P DC by P RMS. This is the DC power by RMS power into 100. P DC is VDC square by RL. This is the load resistor divided by the VRMS square by RL into 100. RL and RL get cancelled, so efficiency is equal to VDC square by VRMS square into 100. VDC is we have calculated as Vm by pi square divided by Vm by 2 square into 100. So we can write it is Vm square by pi square into Vm square by 2 square, that is 4 into 100. Vm square get cancelled, so it is 4 into 100 by pi square, or we can write it is 400 by 3.14 square. On calculating, it will be approximately equal to 40.6%. This is the efficiency of half wave rectifier.